Hello, ladies and gentlemen. It's very good to be with you again. This is Dr. Skinner. We are now moving into one of our final classes in regards to the SDLC. And this is the last class in the design phase. We do the second part of designing distributed internet systems, chapter 12b. What are our learning objectives today? Well, identifying the current trends that help organizations address infrastructure-related challenges. And we're going to talk about some of the standards of design for internet-based systems, consistency in the internet-based design environment, and some of the site management issues that we need to be aware of. And your assignment for this chapter will be based on these elements as per normal. Right, so where are we? We're now in the very last part of the design phase of SDLC, which is very good. So think about how far we've come through the whole of the semester, looking solely at planning, analysis, and design. And you can really, truly appreciate the impact of doing all the preparation up front to the level and detail that you need to do, and the relative little time we spend on implementation and maintenance, even though they're very important. Time we spend with them is so much less, because if you do the work up front properly, then the actual implementation and ongoing support of the environment is hopefully going to be minimized to the degree that it needs to be. Okay, so let's begin by looking at service-oriented architecture. So the thing to think about in this current time is that organizations are generally moving away from large monolithic applications, and they're moving towards this thing we called service-oriented architecture. Let me kind of set the scene. Think about if you have a car, an automobile, right, and you want to go and get an oil change. Okay, so think about the next time you want an oil change. Chances are you're not an expert, and of course, one of you is going to be listening to this and say, "I know how to do oil change my car." Well, Dr. Skinner has no idea how to oil change his car, so I'm going to pretend, and I'm going to assume that none of you know how to oil change your car. So given that you're probably not an expert, you're going to have to take your car to someone who is to change the oil in your car. So what are your choices? You can go to a dealership, or you could go to an independent garage, or you could get an oil change service person, or you could ask a friend. You don't care, really, if the different experts, the different people who do the oil change do things differently from one another, if they use different tools. All that matters is that the service that they are providing is at the expected quality and the expected cost, right? So you don't care as long as you get the service that you want. And this is essentially the analogy that I want to give you for service-oriented architecture, all right? We're going to break our business processes down into individual components, okay? So we are going to think about having these modules that are interactive, that can be used by different component parts. And at the end of the day, whoever's using these component parts, they don't care about big applications. All they're caring about is the service that is provided, okay? So by breaking these business process down to individual components, these services, okay, we are going to be able to focus on making sure that there's an application, or it's another service, or it's a user, or whoever it is able to use our infrastructure or our architecture in the way that it should be. Now, when we think about an SOA, a service-oriented architecture, there are three principles that you can see there at the bottom of the screen. So these services should be reusable, so different applications, different users should be able to use them. Services should work with other services. So this concept of interoperability, which I can't say, I'll try and say it again. Interoperability, there we go. And then componentization. So a service should be simple and modular. Okay, so let's look at this, for instance. Here we have applications. We might have an e-commerce website, we might have a point of sale system, and we might have executive dashboard, right? So these applications want to use the services that we are providing, all right? So they might want to use the infrastructure, the ability to process a credit card, or to ship a product, or to display a product, or whatever it is. They don't care. Let's look at e-commerce website and the point of sale system. They don't care what you do to provide that service. All they want is that service to be provided. So both the e-commerce website and the point of sale system, for example, use the process credit card. Okay, they both invoke the process credit card service. Okay, so all they want is that service to be provided. So if we look at our architecture, if we can break down business processes into individual services, it means that organizations can move swiftly and react to challenging business needs, right? So we can reuse the process credit card service for multiple applications, for multiple users. We're going to be more competitive if we can have a service-oriented architecture. So multiple applications can therefore invoke the same services. Okay, can we be cloud-based? Absolutely. The thing about service-oriented architecture, it does need a tremendous effort and expertise to plan it, to select the right services, and orchestrate and deploy these services. And probably the chances are it's going to be beyond the means of small organizations. Um, we can think about services in this context in many different ways. Let's think about web services, okay? One of the most common approaches for deploying a service-oriented architecture is through web services. So a web service, so you can see at the top, is a method of communication between two electronic devices over a network. So for instance, two software systems that may have interactions, but they may have, you have two systems interact with each other. But the thing is, they may have different languages. Okay, so we have one application interacting with another application using a service for one of them. But the problem is they have different languages. Okay, so we need to think, okay, how can we get these two electronic devices, these web services, if you're interacting over a network, how can we get them to interact with each other? Okay, so organizations, as you can well believe, can have a complex array of technologies that need to interact with different types of systems and devices. They'll need to execute data, they'll need to execute business logic, they'll need to execute process, and so on and so forth. What you'll find typically is such services on the web provide output coming out of them in this thing called XML or JSON. Okay, they don't typically use HTML, markup language, because it has limitations to what it can do. Okay, so there are specific rules for web services governing the communications between systems, and they utilize typically XML and JSON files for data exchange. Okay, XML, extensible markup language. Okay, this internet authoring language that allows designers to create customized tags. There we are reading it, enabling the definition, transmission, validation, and interpretation of data between applications. So XML is readable by humans and machines. We'll look at an example very shortly. JavaScript, object notation, JSON. Whoever came up with these names, you know, they just kind of, let's think of a name that people can remember, and JSON was easy to do. So what's it say? A lightweight data interchange approach that is relatively easy for humans to understand and for computers to generate or interpret. Okay, so we're talking about web services, we're talking about applications online interact with each other. If they want to share data, if they want to exchange data, typically these systems will use either XML and or JSON, okay, to facilitate their interaction. Let's look at some examples in the next couple of pages. So here we have a data example. So we're formatting data within a web service environment. This is JSON. So as you can see, it's very simple to understand. It's very easy to format, okay? It's lightweight. It's probably quite efficient to transfer and to process, and you'd literally add this in to your data exchange between your web systems online. XML, slightly more complicated. XML defines a set of rules for encoding documents in a format which is both human and machine readable as well. It looks similar, if you know, to hypertext markup language, to HTML. There are very strict rules on formatting tags insofar as being able to define what different data mean. I'm not going to ask you to give me examples and define whether something's XML or JSON in the exam, but you just need to know about XML and JSON. Now, when it comes back to web services, there are two technologies used to assist in the communications within a web service environment. And these are what we call SOAP or REST. JSON, SOAP, REST, XML. It's not getting any better, is it? No, I know. So SOAP, Simple Object Access Protocol. So this is a protocol for communicating XML data between web service applications and an operating system. So what are we doing? It's probably more complicated than REST below. It does give you this rich framework for representing the request. It's verbose to compose, but slower to transmit than REST. REST is this representational state transfer. What does that say? Relatively simple and fast protocol for communicating JSON data between web service applications and an operating system. So simpler than SOAP and less expressive. So just remember that SOAP is a protocol for communicating XML, and REST is a protocol for communicating JSON data between systems and applications. Okay, that's fine. So we understand there's a relationship between SOAP, our simple object access protocol, and communicating XML data, our extensible markup language, and then our representational state transfer protocol for transferring our JSON, our JavaScript object notation. When it comes to designing internet systems, which is kind of the context that we're looking at in today's class, most of the new system development, as it says here, is focused on internet-based applications, okay? So we're looking at internal processing inside an organization, we're doing business to business applications, we're doing business to consumer. We're obviously taking advantages of globalization, right? That's the whole point of the internet from a business perspective. So there are numerous choices that have to be made when I'm designing an internet system. And the design choices that are going to be made can greatly influence the ease of development and future maintainability of any systems. So when I'm designing an internet systems, I have to ask myself, what are the main issues that I need to be aware of and that I need to deal with and make sure that I have taken into consideration when I'm designing my system. And as you can see them there, we have 6 of them. We've got to think about our standards. We've got about how we separate our content from a display, how our current version is going to evolve into future version in a seamless fashion, whatever our internet system is all about. The whole of our site has got to be consistent. We've got to be able to manage our site, and we've also got to manage our online data. So let's look at these in a little bit more detail. Now, standards. The good thing about standards is that internet design, as it says there, is simpler than client server because we have so many standards that we all have to follow. And you can see 3 standards that you probably are going to be aware of. So the first one is domain naming. I never knew BIND, Barclay Internet Name Domain, in the old days, because that's what it stood for, which is basically our method for translating domain names into internet protocol addresses. So 129.7.241.0-55 is uh.edu. So there's this domain naming protocol. Next one is Hypertext Transfer Protocol, HTTP. It's communication protocol for exchanging information on the internet. And then the last one, HTML, Hypertext Markup Language, standard language for representing content on a web via command tags. So for instance, if you knew the formatting for bolding text, you could just put outward facing arrows around the text with a B in the middle, and that will give you bold text. So Hypertext Transfer Protocol, this is all about how messages are formatted and transmitted. You enter an URL, an HTTP command is sent to the appropriate web server requesting the desired web page, and so on. So given these standards, designers can quickly craft systems because much of the complexity of the design and the implementation is obviously removed. So it's interesting. So hopefully you guys will have a very kind of inherent understanding because you've just grown up with this. I can remember back in the day when I was your age, the internet was just coming into existence, and trying to understand the early versions of all these standards was very, very complicated. But now it's much more simple, and hopefully you guys have that understanding inherent to hand. Now, one of the other things you've got to think about, we often take for granted, is site consistency. Okay, so if I have a website, I want all the multiple pages to be consistent. A consistent look and feel to a website is fundamental to conveying an image that a site is professionally designed. And we want to be thought of professional, right? We want to elicit feelings of trust. We want to, our clients or whoever wants to use or interact with us in an organization to have this perception through our website that we are professional, we know what we're doing, we are trustworthy, they want to give us repeat business, and so on and so on. So we want to portray ourselves as being professional. And so professionalism, as it says there, requires consistency across all pages of a website. So the question becomes, how can I make all my pages consistent? So one of these things we can use is this CSS, this cascading style sheet, the set of style rules that tells a browser how to present a document. And essentially, this is just a single file that needs to be updated when changing elements across an entire site. So if I make changes to one file, it'll permeate across all the whole entire site, and it will allow us to be consistent in the way that we present our website. So CSS helps to standardize the look of different types of HTML hypertext markup language elements, and it also formats HTML tags. It makes things easier to navigate. It makes it easier for users to anticipate the meaning of links. Something else that I can also work on as well as CSS is XSL, this extensible style language, which is a specification for separating style from content when generating HTML documents. So it allows for transforming XML documents into a generic comprehensive form, and then formatting the generic comprehensive form into a device-specific form. So XSL transforms XML data into presenter form in HTML or WML. Okay, it's more sophisticated than CSS. The consistency of an XML content displayed on different types of client devices. So it allows you to do more than what you could do with CSS. Actually, what you can do is take both, and if you can use both, then you're going to do very, very well. So if you want to combine XML and XSL, we've got to remember, we can do so, we've got to remember that XML is the language that defines a set of rules for encoding documents in a format which is human and machine readable and used to interchange data over the internet. Okay, so XSL separates style from content when generating XML pages. Very good. So let's think about site management design core concerns. We're thinking about design issues related to site management. So we want our customers to feel that our site is secure. We want to convey trustworthiness. We want our customers to build trust from positive experiences gained while interacting with a site. Okay, so how can we acquire customer loyalty and trustworthiness? So here we have 4 recommendations. Design quality. We want to have a professional appearance. Second one, upfront disclosure. We want to disclose all aspects of a customer relationship. So for instance, we don't want to suddenly spring surprises on our potential clients as they are looking to place an order with us. If I'm selling something on the internet and I sell it for, I don't know, $70, and they go, okay, it's going to be $70, and then suddenly at the very last page of the interaction, I spring shipping charges of $130, that's not going to be beneficial to building trustworthiness and loyalty, because we're not disclosing, we're springing surprises on them. We want to give them this upfront disclosure as honestly as we can so that they can build trust as a result. We also want to have comprehensive, correct, and current content. So everything's got to be up to date. And of course, we want to be connected to the rest of the web, right? We don't want to have dead links. We want to generate this sign of confidence, this credibility that we are who we are, and people know that. So one thing we can do, or 2 things, I apologize for saying, 2 things, we can focus on personalization and or customization. So personalization is providing internet content to a user based on knowledge of that customer. So think about Amazon. Next time you log on to Amazon, you are going to get content presented to you based on your previous shopping experience. That's personalization. Customization, allowing users to choose the content and look of the site based on their personal preferences. Okay, so personalization, customization. You're going to be looking at personalization and customization in your assignment for today's class. Another thing we've got to think about from a site management design issue is the relationship between security, functionality, and ease of use. Okay. In this context, the first thing to note is links. We're going to have links inside our website, and these links should always be live. They should always be functional. They shouldn't just point to something that doesn't actually work. You know, the number of times you get frustrated, you've got a problem, you might go and say, oh, this answers the question, and it just, web page is no longer available. Okay. That's so very, very frustrating. So links must live forever. The thing to remember as well is it's got to be secure, it's got to be functional, and it's got to be easy to use. But these are all, this relationship between security, functionality, and ease of use is somewhat paradoxical, because if I want something to be easy to use, then I'm going to have to compromise my security, possibly. If I want something to be functional, it's possibly going to compromise my security. If I want secure, then I'm going to have to compromise perhaps my ease of use and functionality. You know, think about functionality. If I log into Amazon and I say, remember my password, so I just click on Amazon, it takes me like straight away into my account, I'm compromising my security. But it's easier to use, it's more functional. So system security versus ease of use and the use of cookies is you have to kind of find that sweet spot in the relationship between each of these different component parts. What else do we have to think about? We need to think about site content management. So CMS, a content management system, is a software application that collects, organizes, and publishes website content. So we might get this from data warehouses, we might get personal databases, we might have inventories, we might have lots of different sources of content that is relevant to us. So we can take all this content from multiple sources and we can format it to ease our site management. So this allows us to have a very good appreciation and understanding of understanding the relationship between different sources of data that is relevant to our environment. A data warehouse, I just touched there. If you don't know what a data warehouse is, as it says here, what does it say? A subject-oriented, integrated, time-variant, non-volatile collection of data used to support a management decision-making. Wow. Essentially, a data warehouse is a read-only environment where if you're making decisions, if you're a senior manager, you want to have access to historical data, historical information, which has been aggregated from different sources that allows you to look back, to look forward. So if you're trying to make a decision about strategic direction of your organization and you want to see how forecasting has evolved from previous data, then you might go to a data warehouse to have a look at that data. We talk about this in the administration of an information-based computer system, my other class that I teach. So what are the key features? So it's all subject-oriented, it's organized around key subjects. We integrate data from many different sources, operational systems, and so on and so forth. So time variant contains a time dimension, it's all historical. Non-volatile, read-only, data cannot be updated by users. So you wouldn't have a data warehouse system being stored in an operational system, because obviously in an operational system you've got a lot of churn, and we don't want that to interact or to influence our data warehouse data. So it's used to help make decisions. So there are 4 broad elements in a data warehouse. The first one that we do is extract data from various different source files and databases. You can see on the left there. So it might be a source file, it might be a database, different databases and external sources of websites. What we do is we take these all together, we clean them, transform them, integrate them so they're all in the right format. We then put it into our data warehouse, which is our read-only environment, and then users can access that using query languages and do analytics like business intelligence and so on and so forth. And that's the source for them to be able to making decisions. When it comes to data warehousing, there are 2 types of architectures, either 2-tier or 3-tier. 2-tier is your basic data warehouse and a decision support environment. pretty much what that is. A three-tier is an operational systems and data context. Then we have our enterprise data warehouse. What's it say? Let's read it. A centralized integrated data warehouse out of the control point and single source of all data available to end users or applications throughout the entire organization. And then data marts. So data warehouses, it's kind of like if I'm in the accounting department and I want to have access to a small component part of the data warehouse, then I can have a little corner of the data warehouse put aside for my data that is relevant to me from across the enterprise, but it's just for the context of the accounting department. So data mart is that smaller version. So we can see it here, for instance. We'll have our transformed and integrated all the different sources of data. You'll go into our enterprise data warehouse, and then we can take component parts that are relevant to my world, as if I'm in, let's say I'm in an accounting department, and I can have access and control only that small area that is relevant to me to make a decision.